In this video, I'm going to talk about the gear set and just some general information about where the gears are, the synchro mesh, the general construction of it. This is probably not going to be relevant for the vast majority of people, but I'm just going to put the information, or as much as I possibly can, from my amateurish knowledge and from what I can see. So if there is a shop or someone who's pretty hardcore into this, they've got some information to start with before they jump into this. So to start with, we've got the two input shafts. On the outer of the two input shafts, there are only 3 gears, so we've got second, fourth and sixth. Second is machined as part of the shaft. On the inner input shaft, because the outer input shaft stops just in there, we've got the speed sensor here, which is pressed on here, and then machined as part of the shaft is first here, but also that locks into second because the idler gear would be, actually it sits in here to go into reverse there. We have third, fifth and seventh. Now the gears on the other side here I've removed just so I can show you the construction of how that's all put together, but that's where all the gears are. On the output shaft, obviously you've got the corresponding gears for each of those. The shorter of the gears, so first, third, second and reverse, have triple synchro mesh in here. You've got the shifter here, which is between second and reverse, and this one here between first and third. And then on the input shaft, you have the longer of the gears. So we've got sixth and fourth, and then you would have seventh and fifth back here with an equivalent shifter like that back there, which is where that has come from. The shorter gears, so those 4 shorter gears, have triple synchro mesh, and I'll pull these apart in a moment, just show you how they're put together. The longer gears, so those there and the 2 back here, only have a single synchro mesh. The shift rods are a one-piece construction. They're all welded, so the forks can't be disconnected. They've got a plastic thing which looks like it's molded onto the metal at the ends, which runs obviously in the slider. You've got the gear indication magnet there, which is a thing that's detected by the distance sensor. For the shift rods, they have these notches in them in various places, and they serve 2 purposes. The first one, each of them has this spring-loaded thing here which goes into the notch, so that sort of holds it into that central position when there isn't a gear selected. So they all have those around here, but then they have these lockout pins. So there's that one there, there's another one here, and there's another one in here somewhere. But what they do is they lock the gears out against each other. So for example, in this case here, that if I push that forward, that would be selecting reverse. That pin would go down. There's another one down here which would go down into that shift rod that was there. And it also, via sort of various means, goes to this shift rod as well via back here. It stops those gears from being selected. So when reverse is selected, it's locked out against any of the other forward gears. But also via these things here that sort of push, like this one here would push into an equivalent position on the other side here. So if this gear was selected, so it's either moved forward or rearward, that thing's pushed up, now this one can't move. And there's another one inside here as well at the back here, which is not shown at the moment. Not important to show it, but enough said that that's the way the general construction of the gear lockout system is. The general construction of all of these is that you've got a gear like that and that one with a needle roller bearing on the inside. That would be running on that part of the shaft there with that gear sitting there like that. We've got the synchro mesh on the inside, and then we've got the hub and the slider. This is able to move left and right because obviously it can just move with those bearings, but we've got the hub, which is pressed, and it's a pretty solid interference fit onto these splines there. And then on the other side of that, because everything needs to push over that, you'll have another sleeve, which is an interference fit, and then that would fit into the bearing on the other side. So in the end, you end up with something that looks something like that, where we've got that gear just running freely on that part of the shaft there. Interference fit from the hub onto the splines there, and then this one here can move, but this sleeve on the underside is pressed onto there, and then we would have, in this case, it's just a washer that's press fit on the back, and then that sealed bearing at the back. Up the front here with 4th and 6th, this one here would be reasonably easy to remove, I would think. There's just a press fit washer on the front, which is the same as the back here, which I reckon would pop off pretty easily. You'll have an interference fit on the sleeve underneath that bearing, and on the hub, I think this would just come straight off. Problem is getting this one here off. There's a circlip at the front, but then this is machined as one piece, that gear. And I think there is an interference fit for the spline all the way along here. Well, there's no way I was going to get this thing off. And I think the reason it's like that is because the natural rotation of the engine and the torque that's applied with the cross-cut gear, or the gears with the angle on them, any gear that's like that, which is all the forward gears, it's going to try and push those gears that way. The bottom ones is going to try and push them that way. So this needs to be super secure, and the problem is here, there's only a needle bearing in the front case. So this needs to be very solidly on there. That circlip, whilst it's just there, it's not going to hold that much if there's a lot of torque involved. So it looks as though there's a lot of interference in here that would take a lot of force to get that out. Maybe heat that up prior to removal, don't know. I don't have the experience or knowledge to be able to do that, but that's what I think is going on. And once that's off, and then this could come off. Don't know about these, whether or not these are also an interference fit. That's the output to the pinion shaft. Or whether or not these will just slide straight off a spline. Don't know, you'd have to find out when you get there. And so that construction is pretty much the same everywhere from what I can see. So, for example, these bits here at the back, so for 5th and 7th, these will just slide straight off a spline. This one here will just move straight off. There'll be a sleeve underneath that. The hub in here will be an interference fit. And this one will just be able to move freely. So when you're pulling these off, you'd have to pull from back here, or probably even from the reverse gear here to pull all these forward, and you're disengage the interference fit from the hub here and the sleeve that's underneath this bearing on that gear, and then the whole lot should just slide straight out. I tried to whack out the center of the 2 input shafts, and I couldn't get it out. But what I did notice on the inside, that there is a seal very similar to that one that seals the 2 shafts. I could also see there was a needle roller bearing on the inside. And so what I'm expecting is once you basically disassemble most of this, certainly all of this needs to come out because I can't get this past the impulse wheel here without removing that. And then hopefully you'd be able to press the whole thing out. Again, I don't know the construction. There looked like there were multiple sleeves inside here that were holding on to different things. So without being able to pull the thing apart, I can't really tell you a bunch of what's going on in there. I'm just going to talk about the synchromesh and the different types and the way it all works in the transmission. I'm not an expert in this stuff, but I'm just going to talk about what you can expect to see if for some reason you decide to pull all this stuff apart. The synchromesh has either single or triple. So basics of synchromesh, there's my hub, there's my slider, it goes on that. That is going to run inside there like that. And the hub is spinning different to that, and obviously what we're trying to do is as we push these together, get them going at the correct speed, or the same speed, so then that can slot in there like that, and then the 2 are joined. And then when you take it out of gear, that happens, and now, hopefully they won't grind like that. Now they can run separately. This one here, the hub, that as you can see is spline, so that's solidly connected to the shaft. This one here has got a bearing on the inside, so that can just run freely. And the way the synchromesh works is, and this one here, and this is one of the longer gears where you've got a single synchromesh. Basically got a ring that sits in between, and some of these are brass, some of them are like this, so all of them in this gearbox have this friction material, which is, I'm assuming, very similar to what you'd find in a clutch pack. and it's a cone shape. So as pressure is applied, so this is going to be connected to the hub and spinning with it, and as this pressure is applied, the friction material on the inside of the cone slows everything down, so these then go at the same correct speed where they can interlock and join together. For the triple synchromesh, which is this one here, and these are on gears 1, 2, 3 and reverse. There are 3 bits. Let's pull this apart. So it's those 3 cones. So I've still got the cone like that, and you've got an inner piece there, a central one. You can see the central one is the one that's going to be spinning and connected to the gear, and via all these pins, the let me just join that together. The outer and the inner are now going to be connected to the hub. So if we look at the hub, which would be locked into, and this is of a single synchromesh one, these are a little bit different size, but that would be locking into a similar position like that in there. So this is spinning with the hub. The way these get pushed together is in the middle here. So if I've got my slider on like that, in the middle here there's a little thing called a strut, and what that does is, now this is off the triple synchromesh, so this isn't going to fit in here properly, but it shows you what's going to happen. It's going to be sitting in here, and as we push the slider sideways, there's a notch on the inside of the slider. Not sure if you can see that in there. So the little ball bearing that's spring loaded sits in there, and as we move it sideways, it pushes it, and it pushes it against the synchromesh. So in this case here, it would be pushing it against that, which is the thing that applies pressure, which then slows things down. And then as it slows down, everything gets to the right speed, then the thing slides across, and then the little ball bearing, as it's been pushed and this thing goes sideways, goes clunk out of the slot and stays there like that, until then when you put it into a neutral position, it goes back to that position again, and then when you move it the other way, it's going to push it and then click once it actually goes into gear. So whilst the hub is slightly larger for the triple synchromesh, and these things just sort of push straight in, for the single synchromesh, all they have is, it's a little spring that sits in there. Here's your strut there like that, and there's a little ball bearing that sits like that in there with the spring pressure on it, and that's the thing that is going to obviously be pressing on the inside of the slider. And as you can see, our synchromesh slots in there like that, so when it's pushing sideways, I'm just going to move that ball bearing out of the way, it's going to push it like that, and then once it gets pushed all the way across the slider, this is going to plonk back into the central position again. If you're pulling this stuff apart, for these it's pretty simple, because these plastic struts just sort of stay all together, which is kind of nice. With these, everything just springs out all over the place. So if these automatic with the slider on it want to sort of go off to the side because of the spring pressure, my advice is when you're pulling these off, cover them with a rag if you are pulling them apart, and then pull them apart with the rag covered. Everything will spring apart, and you'll be able to collect everything, and it won't be on the other side of your shed. The connection points at the hydraulic end, so we've got a little cylinder that's pressed into the case. It's got an O-ring on the inside that needs to be put into the casing, and then you push that into place when that's installed. After the shift rod is in there, it's got an O-ring around the outside there, which needs to be installed obviously prior to installation. On the inside here, there is this hydraulic seal, and that's one's been pulled out, and that would run on the inside like that, where the notch in it faces the piston, because that's the thing that's going to press down and create the seal as pressure is applied to the inside here. That's, I'm not sure if you can see there, but there's a plastic sleeve on the inside that can move, and it goes in on this side here, that seal, and it gets pressed into the gap all the way down in here. It's pretty easy to put it in there and pull those out if required. But with all those O-rings and seals installed, that just gets pushed in there. That would fit on the end of the shift rod like that. It's got a screw on the end that also has an O-ring in there. That's an 8mm by 1, so it's a fine thread. I've put 22 Newton meters on those and they seem to handle that perfectly okay, so that's what I would use on install. So when everything is installed, it's going to look like that inside as it's moving, and it's funny because it's got this wear here, but it's never going to go past that there. So I don't know where there's wear mark, maybe this comes from the factory, it's all a bit weird, but when it's selected all the way rearward, it's going to look like that. When it's selected all the way forward, it's going to be like that, and it's going to be about there somewhere in the middle.